Hello everybody and welcome. Welcome. It's your friendly neighborhood mathematician Root Beer here, and I thought we'd start another contest in this series of videos. We've done the 2011, the 2012, the 2013. It's high time we did the 2014 CSMC math contest. Okay, the CSMC put out by the lovely people at the Center for Education in Mathematics and Computing. They're located at the University of Waterloo in Ontario, and they put out these fine contests. So let's take a look at another fine contest, 2014 CSMC. Okay, it's the paper for the grade 11 and grade 12 education level. It's 2 hours long, and as we've seen before in the 2011, 2012, and 2013 papers, which we've done before, it's got a Part A, Part B. Part A worth less in terms of marks, but it's got, you just need the final answer, whereas Part B we need to write out solutions, justify what we're doing. We have a whole bunch of notes here, things that you should take to heart if you're going to try these contests and actually compete here. And as I try and mention each time, before you watch this video, before we get into the questions, go onto their website. I will put a link down below and try the contest for yourself. You learn so much more when you try it on your own and then come watch these videos or then read the solutions. But yeah, so we'll make these videos sort of as prep in case you want to someday write these contests, or maybe you're just curious as to how the solutions are done. But either way, if you're going to compete, take note. Always try and read things beforehand. But let's get into it. We didn't come here for the preamble. We came here for the math. So let's get into Part A, question number 1. It's a diagram-style question. So in the diagram, ABCD is a square. Okay, so it's going to have the constant side length, and these are all going to be right angles in here. Triangle ABE is equilateral, and triangle AEF is equilateral. What is the measure of angle DAF? So this angle, it splits it right here. Okay. Well, for this sort of thing, we're just going to need to do some diagram chasing. We're going to need to fill in angles. We're trying to find DAF. But we know, being a square, we're going to have angles of 90 degrees in the corner. Equilateral triangles, both of them are going to have angles at their vertices of 60 degrees. And so hopefully we can combine these facts and figure out what exactly the measure of DAF is. So let's get ourselves a piece of paper and get going. Always a good idea to draw out the diagram again for our own purposes. Doesn't have to be perfect. Very few of the things I ever do are perfect. But certainly diagrams, they don't need to be. They're only for your purposes. If you want to, I guess you can be really anal about them, but you're going to waste time on contests. So that was A, B, C, D. Then we have equilateral triangle in here. D, E, F. Or sorry, A, E, B. And then we have another one down here. Well, that's a pretty awful equilateral triangle, but we still get the gist of the relationship. And we want to solve for this little angle in here. We're going to highlight him with, let's go with lavender. That's the one we want. We want that angle in there. We'll switch back to the black pen for our pontification and our justification. Remember, you don't need to justify your answers in Part A, but it does help to earn you part marks if you made a calculation error. Okay. So, I noticed that angle DAB is 90 degrees. Since ABCD is a square. Okay? Another thing I can notice about DAB is that the line AE sort of splits it up into angle DAE and angle BAE. Okay. But I know the angle of BAE. It's going to have to be 60 degrees, since triangle ABE is equilateral. Okay. So at that point I know that DAE, I can rearrange this equation and find DAE is going to be 90 degrees minus 60 degrees. That's 30 degrees. Fantastic. Okay, so we don't quite have the angle we want, but we have the angle that's next to him. So we can fill this in just a little bit. $60 degrees and 30 degrees, and this whole thing here is a right angle. So another angle I can notice is FAE. It's also going to be 60 degrees. Why? Because AEF is an equilateral triangle as well. So FAE, well, that's angle DAE. See this line DAE? It splits it right down the middle. It contains the angle we just figured out and the angle that we want. We want angle DAF. That's why we're highlighting it again. So what's the relationship? It's the sum. We can rearrange this equation and solve for DAF, which is exactly the one we want. Is going to be angle FAE, which we just mentioned is 60 degrees, minus DAE, which we figured out was 30 degrees. So we get 30 degrees, that's our final answer. We didn't need to write out all this exposition, but if for some reason we had a calculation error, we screwed something up, we could get part marks. But if we go back and look at question number 1, that's all we were asked was what is the measured angle DAF? We've got that. It's 30 degrees, and we justified it a little bit too. But if you didn't want to, if you sort of knew what you were doing, you could just put 30 and move on. That's a great time saver, but it does come with a bit of a risk. But of course, if you're writing the contest, the choice is yours to make. So it's a great starter question with a little bit of angle chasing around a diagram with some familiar objects, squares, equilateral triangles. Good start to the 2014 CSMC. Join me in the next video as we take a look at question number 2.